The EIP 1559 upgrade burns transaction fees that used to go to miners. At the time of the making of this video, upwards of 350,000 Ethereum coins have been burned since the EIP 1559 upgrade has been launched. Now in this video, we will go over how to automatically send tokens to another address, very similar to how the EIP 1559 upgrade is set up. Now whether you would like to implement a tax on a transaction, contribute to a particular fund like a non-profit organization, or just want to create your own deflationary token, being able to automatically send tokens can prove to be very useful in crypto. So in this video, we're going to look at two different use cases. Now the first use case involves a user sending funds to a smart contract, and a percent of those tokens sent are sent to a different address automatically. And the second use case that we will be looking at involves a user initiating a token transfer between two parties, and a percent of the tokens transferred are sent to another address. So to get a clear understanding as to the two different use cases, we are going to go over a diagram explaining each. But before we get into all that, you know what time it is. If you haven't hit that subscribe button or that push notification bell, go ahead and do that right now. I don't know what you're waiting on. Just go ahead, just click right there.
Just do it!
You know that little bell, that ding, right there. Push notification bell, do it. There you go. Also, we'd greatly appreciate any constructive criticism or negative criticism, if at that. Go ahead and hit that like button, as well as comment on the video if you find this information useful, or if you have any questions regarding the code or anything that we go over within this video. Now let's jump into these diagrams. Now for the first use case, let's say we have a user, and we're going to call this user Dro. Now Dro wants to send 10 ETH to a particular smart contract. So this user, sorry for the handwriting, will send ETH to this contract. Now the balance of this smart contract will now be 10. However, the smart contract is programmed to keep 9 of the ETH and send out another whole ETH to another address. Now this address, it can be anything. It could be a user, it could be a fund, it could basically be anything that you want it to be, as long as it has an address to send it to. We are going to have the same user Dro, and he is going to start off with 10 ETH as we did earlier. Dro initiates a transaction by transferring his tokens to a smart contract. However, this smart contract is going to disperse 9 of the tokens to another user. Let's call him Alex. And it is going to disperse 1 token to another address. Now, this address could be, as stated in the first use case, could be anything. It could be a nonprofit organization. It can be basically anything. But this smart contract essentially processes the transaction and sends a certain percentage of the transfer to another address. Now, once again, the target address can be a smart contract address, a burn address, just about anything else you could think of. So let's go ahead and create this on Remix. All right, guys, so let's go ahead and apply what we just learned into our smart contracts. So let's go ahead and open up Remix IDE and create a new smart contract. Now, this particular smart contract, I'm going to be calling it use case number 1.sol. Now, what we're going to do is we're going to start off with a little license. This is just a comment for you guys that don't know that these two forward slashes just indicate in Solidity that this is a comment. And we're just going to declare this license identifier as MIT. And the reason for that is sometimes Solidity, for some reason, requires that, doesn't require it actually, it makes it optional that you put a license identifier, and it won't stop you from deploying your contract, but it'll just give you an annoying little warning sign. So I'm going to go ahead and declare the version, the Solidity compiler version that we will be using, and that's going to be 0.5.17. And I'm going to go ahead and name this contract burner. Now, let's go ahead and declare a destination address where the funds, a percentage of the funds that go into the smart contract will be sent to this particular address. So destination, and I'm just going to go ahead and get an address from my MetaMask. If you haven't already, go ahead and get some test ether. As you can see, I'm on the Ropsten test network. I have 1.8 ETH, which is more than enough for me to use within this smart contract. But yeah, like I said, guys, if you don't have test ETH already, go over to the Ropsten test faucet and you can get a few ETH per day. Now, I'm going to declare the only function in this smart contract, and it is just a fallback function. Now, this fallback function is going to be payable, and we are declaring it external. Now, for those of you that don't know, a fallback function basically is a function that the smart contract can quote unquote fall back on when nothing else is being executed. So as you can see, no other functions are here. So the function the smart contract kind of defaults when executed to this fallback function, hence the name fallback function. And so we are going to set up the transfer to the destination address, which is this one right here. We're going to do message.value, which is the value of the funds that are being sent to this particular smart contract. And we're going to divide it by 500. Now, by dividing it by 500, I'm essentially sending 0.1% of the funds that are being sent to this smart contract. I'm sending that over, 0.1% of that over to this address, okay? And that's why I'm dividing it by 500. Now, instead of 0.1%, if I wanted to send 1% of the funds over to this address, then I would just change this to 100, okay? And so on and so forth. You could change it to your liking. Let's go ahead and compile this. And that's basically it for this particular use case as far as setting up the contract. So as you can see, I'm already connected to this account on my MetaMask. Now what I'm going to do is I'm not actually going to deploy it using this account. I'm going to switch over to another account. Let's switch over to account number 3. Okay, I have 5.5 ETH here. So contract burner use case 1. Let's go ahead and deploy it. As you can see, it is pending creation of burner. Here we go. Everything checked out smoothly. Let's go ahead and open this. As you can see, there are no functions here, just like I stated earlier, because all we have is a fallback function. So let's go ahead and retrieve the address. Well, first off, let's get the transaction hash to this particular transaction of deploying the contract that we just created. So I'm going to go to test, or better yet, Ropsten test etherscan. All right, now keep in mind, guys, this is the test explorer, not the regular etherscan explorer, the mainnet that everybody's used to. Okay, so let's go ahead and paste our transaction hash here. As you can see, this was a success. timestamp was about a minute ago from this address, which should match up with my MetaMask address 0xCFOE 0xCFOE to contract address OXEA426. Now, this is the new contract address for our particular smart contract. So now that we have an address where we can send funds to, let's go ahead and send funds from this account number 3. We'll go ahead and copy the contract address. Let's send funds to this address. I'm going to be sending, say, I don't know, 0.3 ETH. This is 0.5. 0.5 ETH. All right, so I'm sending it from account number 3 to the smart contract address, OXEA42, OXEA42. Confirm. And the transaction is pending. Boom. Now, as you can see, 0.5 ETH has been sent. It has decreased from this account. So let's go ahead and load this page. And as you can see, as of 58 seconds ago, we have received a value of 0.5 Ether to this smart contract. So let's go ahead and open up this transaction hash. Now, this is the important part. So the contract, remember, this is the transaction details. So the contract 0xEA426, this is the address of our contract. Funds were received from our MetaMask contract 0xCF0 to this contract. And then as you can see, look at the transfer. Transfer of 0.001 Ether from our smart contract address 0xEA426 to 0x355. Now this address should match up with what we have here, 0x355. As you can see, matches up perfectly. Now let's go see if the funds are actually there. And as you can see, it went up. The account went up 0.001 Ether. So use case number 1 fulfilled. See guys, it's not that hard. Look how simple this contract is. Now let's go ahead and jump into use case 2. Now use case 2 is going to be a tad bit longer. However, use case 2 is not complicated to understand. And use case 2, we get a little bit more freedom to do whatever we want with our particular tokens, as well as how we get to interact with our contract. So let's go ahead and create use case number 2.sol. I'm going to go ahead and copy this one line one time for the one time. All right. So let's go ahead and establish our Solidity compiler version. I'm going to be sticking to 0.6.0 for this contract. Now, for this contract, I'm just going to call this one GoFundMe. Because at the end of the day, this contract technically can be set up to send funds to a nonprofit organization. So I don't know, I feel like the name GoFundMe kind of fits the description, if you know what I mean. So let's go ahead and do as we did on the previous use case. We're going to establish an address or declare an address. This address is going to be payable. And the destination of this address, let's switch things up. I want the destination of this address to be my first account. For this smart contract, let's go ahead and establish a mapping. Now, this mapping is so that the state variables for our token can be tracked and the balances can be tested. So unsigned integer. We're going to make this public, and it is going to be called balance of. And this unsigned integer is going to be public. It's going to be the total supply of all of the coins. So in order to have the ability to name our tokens as well as control the symbol of our tokens, the particular ticker, as well as the decimals of our tokens, inside integer 8, we are going to be adding this. Now, let's go ahead and create a token and assign all the tokens to the creator to test. So we're going to start off with a constructor, unsigned integer, now I'm going to name my token Hydro. Now I know what you guys are thinking. There probably is a token. Matter of fact, I know there is. You can look it up on CoinGecko or anywhere else. There is a coin called Hydro, but for testing purposes, remember, we're not on the main net. We are on the test net, people. We can do whatever we want. I could call this Bitcoin if I wanted to. I could call this Ethereum. We can do whatever we need to do because this is a test network. Now for the decimals, I'm going to keep it at 18. The symbol, I'm going to have it as DRO. Our total supply is going to be equal to our underscore total supply. And the balance of message.sender is going to be equal to the total supply. Let's go ahead and make our transfer function. Now, this function is going to have the parameters of the address in which we are sending the funds to, as well as the unsigned integer amount. We're going to make this public. And then we are going to assign an unsigned integer for the portion that is going to the destination address above. We're going to keep it at 0.1%. So I'm going to do amount divided by 500. Next, we are going to declare an unsigned integer for the sender balance. This is going to be equal to the balance of message.sender. And we're going to implement a require statement so that the sender balance has to be greater than or equal to the amount. And if it is not, then we will get an error message saying not enough funds. Now the balance of message.sender is going to be subtracted from the amount. Now let's declare the receiver balance. Now let's go ahead and add the amount _2 of the tokens to the receiver. But remember, we also have to deduct the share that goes towards the intended address. So we're going to plus equal it. Amount minus portion for destination. Now next, we're going to add the share to the intended address. Destination. We're going to insert an assert command so that we can check that everything works as intended. Now, more specifically, we are checking to see that the sum of the tokens in all of the accounts is the same before and after the transaction. So this is just a safety precaution. Message.sender. All right, and there you have it. So now that the contract is all set up, let's go ahead and compile it, make sure everything runs smoothly. As you can see by the green check mark, everything works out fine. Now, remember, for this particular smart contract, we are going to be using 3 different addresses. One address is going to be sending the funds, another address is going to be receiving the funds, and the third address is going to be this destination address. Now, this destination address is going to be receiving the 0.1% tax for the funds being transacted through the smart contract. Now, before we actually deploy this contract, we are going to have to initiate a total supply. So I'm going to go ahead and use, 100 billion as the number for the total supply of our DRO tokens. So let's go ahead and deploy this. Now, as you can see by the green check mark, the contract has been deployed. GoFundMe, and this is the contract address. So let's look at the decimals, as well as the name, the ticker, as well as the total supply. So let's go ahead and check the balance of this address. Now, the balance should be equal to the total supply because we deployed this smart contract with this address. So next, I would like to initiate a transfer of these tokens. So let's go ahead and transfer these tokens, these DRO tokens, from this address to this address. And I'm going to send, say, 10 million. So if it's 10, 1, 2, 3, 4, 5, 6. Go ahead and hit confirm. As you can see, the transfer from the GoFundMe smart contract is pending. And voila, the transaction went through. So let's look at the new balance for the address that created the smart contract. Now that address should be minus whatever this number was. What was that, 10 million? Now let's look at the balance of DRO tokens for the receiving address. That has a balance of 9.98 million, but not 2 million, 200,000 or 20,000. My bad. So there you have it. We deployed 2 different smart contracts. We looked at 2 different use cases for being able to automatically send tokens through a transaction. Well, there you have it, guys. I hope that you have a better understanding as to how to set up a smart contract that automatically sends tokens to a particular address. Now, before I let you go, I must give you a full disclaimer.
We interrupt this program to bring you a special report.
Any code that has been used within this video has not been audited. Therefore, if you choose to deploy any of the particular code that we went over in this video, you are doing it at your own discretion. Please be advised. With that being said, go ahead and hit that subscribe button as well as that push notification bell if you haven't already. Leave a like as well as a comment if you have any questions regarding the code or anything else that we went over in this video. I'll catch you in the next video.